It's nice to be able to come and give a talk after hearing about vaccines and the effect of vaccines and the impact of the anti-vaccine movement, to be able to talk about GMOs and the non-controversial nature of those when Okay, I'm going to spend the next 20 minutes covering a fairly limited number of topics. One is, what is a GMO? What are GMOs? Followed by how prevalent are GMOs in our community, both in foods and crops and so on. And then finally, the number one question that people ask me, sometimes I'll get a phone call or an email saying, Dr. McHughen, I don't know much about this subject, but I know that this is controversial. I don't need an entire course in molecular genetics. Just tell me, are these things safe? That's the number one question. And so I'll spend a few minutes on that. And then if there's any time at the end or perhaps during the breakout if necessary, I know labeling is another issue that's at the top of many people's minds, so I can talk about that as well. But I'd prefer to keep that because that's an entirely, it's a related, obviously, topic, but it can take an hour just discussing labeling itself. It's far more complex than people believe. So what are GMOs? This is a good question. We don't actually have a legal or scientific definition of GMO in the U.S., right? No official documentation, either at the political level or at the scientific level, defines what a GMO is. They do in Europe. The European Union does have an official and legal definition. We don't use it because it's ill-defined. Generally or categorically, it means anything produced using recombinant DNA or genetic engineering, plus a whole list of other things that don't occur in nature. And that's problematic because, as a scientist, we don't know everything that can or cannot occur in nature. And how do you define what is natural? Again, superficially, it seems obvious, but when you think about it, when you delve into it, it's actually a very difficult thing to define. And again, in the U.S., we don't have an official, legal, or scientific definition of natural. We call these things genetically engineered plants or transgenic if they have genes from one species transferred into a different species. In Canada, they're called plants with novel traits. So there's lots of different definitions that people use to indicate things, but by and large, we use the process of genetic engineering as the trigger for something that we call genetically engineered, or perhaps a GMO, genetically modified organisms. Two different, or a bifurcation, a split dichotomy between the process and the product. And this is crucial when you think about it. The process is the method of breeding. So if you use the process of genetic engineering, anything that emanates from that process, no matter how many years, no matter how many generations, no matter how many refinements, can be considered ultimately a GMO. The alternative is the product. We can look at the final product and say, is this genetically modified? Is there a change in the genetic structure, genetic composition of this final product? And regardless of how the thing was bred in the first place, whether it was traditional breeding, mutation breeding using ionizing radiation to scramble the DNA, which, by the way, is considered a traditional breeding method, and something over 3,000 varieties of our crops that we consume on a regular basis were developed using mutation breeding, which most people don't know about at all. In the U.S., we consider a GMO to be a result of using recombinant DNA technology. We don't get into the second category of things that are unnatural because that's just a minefield. Arguments abound, again, just on determining what is natural and what is unnatural, and particularly considering the type of interventions that our plant breeders use genetically on our different crops. Some genetically engineered products. The first one is insulin. All right, first genetically engineered product, first GMO in the marketplace was insulin, produced from the transfer of the human gene coding for insulin into a bacteria. right? And virtually all of our insulin now comes from these genetically engineered bacteria that read the human DNA coding for insulin. The bacteria make the insulin in these fermentation tanks. Companies then extract and purify the insulin and sell it to diabetics and others who use it. Prevalent in society. Chymosin is another early product. This was used and is used now to make cheese. Instead of using animal source rennet as a clotting agent in the milk, people are using genetically engineered microbes to produce this chymosin, which takes the place of that animal source rennet. So over 90% of our cheese now is genetically modified. Flavor Saver tomato you've probably heard of, and many people will say, when asked, what is a GMO, they'll think of the Flavor Saver tomato that has a fish gene in it. Well, Flavor Saver, first of all, is not on the market anymore. It was the first food product, genetically engineered food product on the market, but it never had a fish gene in it. Tomatoes have never had fish genes in them, and even today, there are no fish genes genetically engineered into any foods. Virus-resistant squash, a lower profile product. It's not as prevalent, but it is being grown now. It is on the market, and some squashes that you may buy are genetically engineered to be resistant to this virus disease. Similarly, papaya, if you've been to Hawaii and sampled their papayas, most of the papayas grown in Hawaii are genetically engineered to resist papaya ring spot virus, which is a devastating disease. The papaya ring spot virus resistant papaya was developed at the same time, curiously, that the disease was blown into the islands. So during the testing phases, the scientists who were growing the initial grove of papaya trees noticed that their trees, even though this was an experimental plot, had no symptoms of the virus, and the papaya trees in surrounding fields were being devastated. So they knew, first of all, that the experiment worked, so they ramped up that. They gave it a fast-track status, and it is accredited with saving the papaya industry in Hawaii. And then a whole range of other things. Genetically engineered corn, soybean, cotton, canola, alfalfa, sugar beets. They're the ones that you're likely to encounter, but the food products that you get from those are things like corn oil or soybean oil, vegetable oil, cottonseed oil, canola oil, or sugar from sugar beets. Those aren't genetically modified organisms. Right? In fact, we don't have GMOs in any of our foods because there's no organisms in any of our foods except maybe probiotic yogurts and things. But the organisms stay behind. In fact, even the genetically engineered plants stay behind. When you process a corn plant for oil, you're removing the DNA and the proteins. What you get at the end is corn oil, which is identical whether it's squeezed out of a genetically engineered corn kernel or a non-genetically engineered corn kernel. And that's what, when they say 80% of our processed food contains GMOs, number one, none of our food contains GMOs, except, as I say, these things like probiotic yogurts, which are not genetically engineered as far as I'm aware. And secondly, there are no remnants of the genetic engineering process in what's called genetically engineered, genetically modified corn oil. It is identical to the traditional corn oil. And we also have a multitude of genetically engineered drugs, vitamins, supplements, and so on. Something like 25% of our modern pharmaceuticals are produced through genetic engineering. So the technology itself is prevalent in our society. It contributes to a wide range of products, particularly things like insulin, as I say, but also things that would not exist without genetic engineering. Dornase alpha, if you have cystic fibrosis, for example. You're dependent now upon the technology. And on the food side, you'd say, well, it's not really a dependency. We don't need genetically engineered corn to make corn oil, and that's true. But it does keep the price down. It gives an even supply. It gives a higher quality supply of product. The status of genetically engineered crops. In the U.S., we have three major crops that are genetically engineered: corn, cotton, and soybeans. And something over 90% of American farmers who grow one of these crops are growing genetically engineered varieties. The other 10%, number one is organic growers are not allowed to use genetically engineered varieties, so they have to grow traditional. There are other farmers who don't like genetic engineering for whatever reason, And there are other farmers who the genetically engineered varieties don't actually work on their farm. That is, they don't have the features on their farm, the weeds or the insect problems that genetically engineered varieties provide resistance to or means to control. So over 90% of our farmers who grow these major field crops are growing genetically engineered varieties, and it occurs to me whenever I see these figures, and it's over 90% by the way, in some cases it's up to 97, 98%, I hear people say, yes, I support American farmers, but I don't like GMOs. There's a contradiction there. It's not only us. Argentine farmers, the major crop there is soybean, and over 90% of Argentine soybean farmers are growing genetically engineered varieties. Our neighbors to the north, canola is the major crop in Canada. Over 90% of Canadian canola farmers are growing genetically engineered varieties. In poorer countries, in India, the only crop Indian farmers are allowed to grow that's genetically engineered is cotton, and over 90% of Indian cotton farmers are growing genetically engineered varieties. So you wonder why. I mean, farmers are people too. You wonder why they choose to grow these. They don't have to. They still have access to the older non-genetically engineered varieties, but they choose to grow what they know is controversial. They know some of their customers don't want to buy them, but they grow them anyway. So there must be compelling reasons for our farmers to choose to grow controversial products. So now, as I say, the big issue, the big number one question is this stuff safe? And safety is relative. Safety is relative, and it's also somewhat variable. Nothing is absolutely safe. No scientist, no medical professional is going to say, this stuff is absolutely safe, or this technique is absolutely safe. There's always a relativity, and we even saw that in the previous presentation about the vaccines. The overwhelming scientific and medical evidence that they're beneficial, but there are risks associated with them as well. You can also find individuals, as in the previous slide, there are individuals who should know better, that's my opinion, should know better, but say, whatever you want them to say. So when I'm looking at a controversial issue, whether it's vaccines or GMO in the food supply or in the pharmaceutical supply, whatever, you can always find an individual to say whatever you want them to say. So I ignore those. And I look at professional societies, because in professional societies, you tend to get the full range of expertise. You get the full spectrum of opinions from positive to negative, and filtering out the extremes on either end, you come to some kind of middle ground. Now, when it comes to the scientific and medical community positions on the safety of GMOs, particularly as they occur in the food supply, again, you find situations, virtually, I wouldn't say all, but a great many professional societies have investigated the safety issues with genetically engineered foods, and they come to some recommendation or conclusion, usually in a peer review analysis, and conclude either that these things are generally safe, that is, at least as safe as what we're currently eating, and that on balance the benefits outweigh the risks. Alternatively, on the other side of the ledger here, we have those professional societies that have conducted a study and come to the conclusion that no, the risks outweigh the benefits. So let's go through these quickly. We can start on the generally positive side. The U.S. National Academies of Science has conducted a number of studies going back to the 1980s, asking various diverse questions on safety, from food safety, which was a panel that I served on, I'll disclose that, and environmental safety, what happens when we grow these crops in the field, how are they relative to traditionally bred crops in terms of the ecosystems and so on, sustainability questions, the technology itself, how safe is the process of recombinant DNA technology. Every one of those studies has concluded that the relative safety is very high, the process and the products are at least as safe as the practices that plant breeders do traditionally, and as safe as the foods that are currently in our grocery stores. So that's a very high rank vote. The U.S. Institute of Medicine, similarly. The American Medical Association, the British Royal Society, it's not just in the U.S., but even across the pond in Britain, the Royal Society of Medicine there, the European Food Safety Authority. Now, Europe is generally more skeptical of this technology than American consumers, but even there, their professional societies are saying these products are as safe as what we're currently eating. the European Economic Commission, the World Health Organization, the American Association for the Advancement of Science, and again I'll disclose that I'm a fellow of that organization, the International Seed Foundation, and so on and so forth. Now you'll notice that there are no corporate interests here, right? So there's no Monsantos or DuPonts or Syngentas, and similarly, although those organizations have also reached the same conclusion, they may not have the same degree of credibility. There are also no government agencies. The FDA, the USDA, and the EPA are the primary U.S. government agencies involved in the testing and approval of these products before they get onto the market, and all of those agencies have reached the same general conclusions. And internationally, our partners, the Canadian CFIA, Canadian Food Inspection Agency, Health Canada, the Australian and New Zealand authorities, the British authorities, DEFRA, and so on. They've also all come to these same conclusions, but I've avoided putting those because some people think that those government organizations are all corrupt and owned by industry. So what I've listed here are simply the public professional societies that have, hopefully, are not as corrupt as our governments. So these organizations have all indicated that the products are at least as safe as what we're eating now. And on the other side of the ledger, we have those societies that have conducted a study and said, no, hold on, we think the risks outweigh the benefits. There aren't any. Not a single professional society anywhere in the world has conducted a study on the safety of genetically engineered or genetically modified foods and crops and said that the risks outweigh the benefits. Regardless of what you may have read on the internet, there aren't any. We do have other, more exciting products coming through. Oops, wrong way. We talked about the papaya in Hawaii. People generally don't think of that. That doesn't come up in the arguments because it doesn't fit into the mold of people's arguments against the technology because they don't like either pesticides or they don't like big companies. Right? People tend to conflate, especially things like pesticides. They don't like pesticides, so let's ban GMOs. Well, papaya has nothing to do with pesticides, and it's not owned by a big company. It was developed in the public sector. We also have new, more exciting products that have a greater consumer interest, such as genetically engineered soy with modified oil profile that are healthier oils. Now, some of these can be developed using either genetic engineering or traditional breeding. The end product is identical. You can't tell the difference. We have things like golden rice, which is the beta-carotene or vitamin A fortified golden rice, to serve those communities, particularly in poorer countries, where there's a lot of vitamin A deficiency, which is a very nasty condition. It has not been able to be overcome by all of the other suggestions that people have made. We don't need golden rice. We should ban golden rice and get these people to eat kale instead. That hasn't worked for the last 10,000 years. It's not working today. If you think that that's the way to approach vitamin A deficiency, terrific. Go for it. Grow the kale and feed it to these people. I encourage you. They'd love it. Really. But why are you standing in the way of also trying the golden rice? Right? Organizations are actually campaigning to ban golden rice, both at a political level and also going out and literally attacking the fields where the test plots of golden rice are being grown and destroying those plots, denying at least the opportunity for kids to maintain their sight. I can't see that. More frivolous, perhaps, the non-browning Arctic apple, just approved last month, and the Innate potato. You cut these and they don't turn brown. And you think, well, why would you use a controversial technology for something so frivolous? Well, the company developing the apple, they say, well, what we want to do with this apple, it's not a world beater, sure, we're not going to make billions and billions of dollars from it, but if we can send our kids to school with apple slices that don't turn brown, first of all, the kids may eat them, and secondly, it's better than sending kids to school with a Twinkie. And I mean, that's a pretty good argument. Just one last point. The Innate potato was developed by a company. Both of these are small companies, by the way, that develop these products. I'm not sure how small you'd consider Simplot, but the Innate potato is non-browning, and it also produces less acrylamide in frying. And there were surveys taken, I just saw this the other day, surveys that consumers would actually prefer this because of the reduction in the acrylamide, which is linked with all kinds of health issues. So these innate potatoes, genetically engineered, but they're still fried, French fries. They're not particularly healthy to begin with, but at least you have a less chance of getting cancer from the acrylamide. Non-transgenic techniques are coming along. This is, some people are concerned because we're transferring a gene from one species to a different one, and Mother Nature simply doesn't do that. Well, scientifically, we know that Mother Nature actually does do that. She just doesn't tell you about it. It happens all the time. It's not an unnatural event. But nevertheless, there are techniques have been developed in recent years that don't involve transferring genes at all. It involves tinkering with, slightly modifying the genes that are already present in a given species to give the traits that we're interested in. And a number of those products are coming through the regulatory approval process now. So finally, I'll just wrap up with this. There are no genetically modified organisms in our common foods at the moment, in spite of what you may have read on the internet. Most of the foods that we think of as GMO, or that people want to have labeled at least, are things that don't have any genetically modified products in them at all. And this means corn oil, soybean oil, canola oil, cottonseed oil, and sugar from sugar beets. Those are the primary products. Chemically identical to their traditional versions, right? Chemically identical. There's no substance. There's nothing remaining in the food that we, as a scientist, I cannot detect it. I have a pretty good lab, but if you gave me a bag of corn seeds, or sorry, a bottle of corn oil, and said, can you tell whether this corn oil came out of genetically engineered corn or regular corn, I wouldn't be able to find anything. It's identical. The chemical composition is identical. And we know that hazard, when it resides, is in the substances, the components, the ingredients of the food, not in how the plants were bred many generations and many years ago. So the professional, scientific, and medical communities don't have concerns about the food safety aspect of genetically modified crops and foods. Where there are concerns, and I don't want to say this is entirely risk-free, where we have concerns is on the environment, right? There are some issues there. They're not safety issues, and they're not new. I mean, they're the same types of problems that we've seen in traditionally bred things, and that is the development of resistance, weeds with resistance to herbicides, or insects with resistance to insecticides. We see those with the genetically modified, some of the genetically modified crops, but we don't see it categorically, and this is not new. We know how to manage that type of thing. And so the farmers, going back to why so many farmers grow these things, in the surveys, the USDA conducted surveys of these farmers and asked them, why do you grow these crops? They say, because we get greater yields, we get cleaner crops, there are fewer weeds, there are fewer insect parts in the grain when we harvest, and therefore we make more money from it. So I'm going to leave it there. My time is up, and if we have questions, I'll look forward to seeing you during the breakout. Thank you very much.